So, research and methods in psychology, chapter overview. So, we're going to learn about what is the need for psychological science, what is the scientific method, and what are the ethics in psychology research in both animal subjects and human subjects. Then we're going to get a breakdown of the basic statistics in psychology and in psychology research, and how do we describe data, and what does a significant difference mean? All right, so these are some of the key points that I want you all to know. So why do we need psychological science? Well, humans cannot rely solely on intuition and common sense. All right, intuition is basically known as that gut feeling. When you ever see somebody and you get a feeling, whether it's good or bad, or you meet somebody and you think it's love at first sight, or you get a gut feeling before a sports event and you think one team's going to win, the other team's going to win, or you just have, it's basically that gut feeling. And is it right sometimes? It is right sometimes, but it's not right all the time. And because it's not right all the time, we'd like to put a hypothesis or a theory through scientific testing so that we could see what truths are behind our assumptions. So, sources of intuition, overestimation, right? So we have hindsight bias, right? And hindsight bias is when it's the phenomenon of I knew it all along, right? It involves the tendency people have to assume that they knew the outcome of an event after the outcome has already been determined, right? So usually after something happens, you'll confirm that you believed it was going to happen. More than if you thought that it wasn't going to happen, you'll believe less that you actually didn't think that it was going to occur. And that usually comes from overconfidence, right? So there's a few different types of overconfidence. One of them is overranking. So overranking is when someone rates their own personal performance as higher than it actually is. The reality is that most people think of themselves as better than average. In business and investing, this can cause major problems because it typically leads to taking on too much risk. All right, so investors like to try to predict the market and have their clients invest their money in certain stocks. And every investor is going to think that they are very sure on exactly where their investors should put their money, where their clients should put their money. And a lot of times they're wrong, right? Right. The average businessman in investing can't be as good as the top 10%, right? So a lot of times we'll overrank our abilities, and because we're overranking our abilities, we'll take too much risk. Another is an illusion of control. So the illusion of control bias occurs when people think they have control over a situation when in fact they do not, right? On average, people believe they have more control than they really do. This can be very dangerous in business or investing, as it leads us to think situations are less risky than they actually are. All right, and this can be applied to many other areas of life as well. All right, then we have timing optimism. Timing optimism is another aspect of overconfidence. An example of this is where people overestimate how quickly they can do work and underestimate how long it takes them to get things done. Okay, and then there's the desirability effect, is when people overestimate the odds of something happening simply because the outcome is desirable. This is sometimes referred to as wishful thinking, and it's another way to describe overconfidence bias. So, why do we need psychology? Well, some of the reasons is we overuse our intuition and make errors, the hindsight bias, the overconfidence, and our tendency to perceive patterns in random events that often lead us to overestimate our intuition. All right, so scientific inquiry can help us sift through reality from illusion. So, the scientific method. Scientific method is the process of testing ideas about the world, setting up situations that test our ideas. Right? So if the data does not fit our ideas, then our ideas are modified and tested again. Right? We make careful, organized observations, and then we analyze whether the data fits what our ideas are. Okay, so a lot of times, well, all the time, a scientific method is started with a theory. Right? A theory is a known part of science in certain categories that we know as a truth. So an example is, we know that sleep boosts memory. So that's a theory. So that's a broad theory of the psychological sciences, right? Sleep boosts memory. So based on that theory, scientists will come up with different hypotheses. And hypotheses are when we make a prediction based on the theory at hand. So if we take the theory of sleep boosts memory, an example of a hypothesis will be when sleep deprived, people remember less from the day before. So, and then we'll do research and observation. So an example of this is give study materials to people before a good night's sleep or an ample night's sleep, and before a short night's sleep, and then test memory. Okay, and then we can confirm, reject, or revise. So we'll go into how we know when we can confirm our prediction or reject our prediction. And this is one example. If we were to do a study on sleep-deprived people remember less from the day before, we'd have two groups. One group would have a good night's sleep, we'll say 8 hours, and then another group will have shortened sleep, maybe 4 to 5 hours, and then we'll test memory. And basically what we're looking for is there a difference between the group that slept 8 hours and the group that slept 4 to 5 hours. Now, if there's a significant difference, which we'll get to at the end of this lecture, if there's a significant difference between the two, and the people who sleep more remember more, then there's more proof that good sleep is correlated with good memory. And we'll get into correlations as well. So we just got into this a little bit. Theory is explanation using an integrated set of principles that organizes observations and predicts behaviors or events. Okay, and a lot of times theories, you could look at it as a broad part of any field of psychology or any science, and then from that broad field of theoretical science, we'll break down and we'll ask more particular questions, which are called hypotheses. So they're testable predictions, often implied by a theory. All right, so a lot of times we'll make a hypothesis based on a theory, the same way above. Our hypothesis, when sleep deprived, people remember less from the day before, comes from a lot of theoretical science that sleep boosts memory. And then we have an operational definition, which is a carefully worded statement of the exact procedures used in a research study. All right, so when we're writing our research papers and we're doing research, we want to give a very detailed step-by-step procedure of what we did. And the reason we want to do this is a lot of times theories and hypotheses are shown to have high credential when they could be replicated. Okay, so let's say this sleep deprivation study, right? We could replicate it. So they'll tell us what were the age of the participants, what was their previous sleeping habits, are they on any medications, where were they living? Were they living in a city? Were they living in the country? All these things that we can try to control, because we want to make sure that when replicating, if we're going to replicate the same study, we want to try to replicate it using the same population of people that they used in the study. And again, you could replicate with a twist. So in this case, let's say this sleep-deprived people was done with, children 8 to 11, and we want to see if we'll get similar results using teenagers, 14 to 18. And then same, we could do young adults, 25 to 35. And then we could do older adults, 45 to 55, and elderly, 65 plus. Right? So there's different things that we could do within a study to make different studies out of a similar concept. Right? And that's what science does. Science makes similar studies based on other studies and just change a few things. Maybe change the culture. Maybe different cultures require less sleep for whatever reason. Now, I have no idea if that's true or not, but scientists will go and investigate these questions and see if they could show that there are any certain significance in any kind of theory or hypothesis. So a good theory effectively organizes, leads to clear predictions, often stimulates research, and may be replicated. Okay? So testing hypotheses, we like to use description, correlation, causation, and experiments. All right, these are 4 terms that we need to know. So descriptive research is a systematic, objective observation of people or non-human participants. Its goal is to provide a clear, accurate picture of behaviors, thoughts, and attributes. All right, one example of a description in research is a case study. So a case study examines one individual in depth, provides fruitful ideas, and cannot be used to generalize conclusions. All right, so a case study could teach us a lot. Everyone should go into the textbook. They talk about Phineas Gage. All right, Phineas Gage had a pipe go through his frontal cortex, and it was a very tragic accident. And from that pipe going through his frontal cortex, his aggression and his morality changed based on that injury. So based on that injury, which we're not going to test in a lab, right? We're not going to go and put pipes through a human subject or any subject in that matter. It's unethical. But if this happens in an accident and we could view a behavior that's significantly different than what the person was before the accident, then we can come to some conclusions based on these extreme cases. So in this case, the part of the brain that was affected by the pipe going through, we can assume or conclude or do more research on that part of the brain's role in morality and aggression. Okay, there was another study of a football star in high school. He was doing some roofing work one summer with his father, and he fell off the roof. He fell off the roof and hurt his head, and he had an impulse to eat after that, where if he was left alone, he would eat everything in sight and he would never get full. And before that, he was a perfectly healthy, young, athletic, smart man. And he fell, hit his head, and from that point on, he had an uncontrollable desire to eat and could not control his eating habits. All right, so obviously they tested what parts of his brain were injured, and that could be, what could that study be used in? Well, we could take that tragic accident of this young man who fell off his roof, and we could use what we learned from it to study overeating, study obesity, study an illness called Prader-Willi's disease, where someone continually eats uncontrollably, etc. All right, so that's an example of case studies. Okay, then there's naturalistic observations, right? Records behavior in a natural environment, describes but does not explain behavior, and this can be revealing. Okay, so an example that your textbook talks about is children, right? We can observe children on a playground. We can observe their behaviors, how they interact with their peers, and we can come to conclusions. We can ask questions. We could look at, analyze their behavior and go forward from there. So that's an example of a naturalistic observation. All right, then we have surveys and interviews, right? Examine many cases in depth, and then there's also effects from the wording. All right, and then we have random sampling, which uses random sampling of the population for best results in various different types of research. So, two parts of research that we should understand are that there's always a population and a sample. So, a population are all members of a specified group of interest to the researcher. So, an example of this could be freshman college students, right, in America. So, college freshmen in the United States of America, all of them would be the population of college freshmen in the United States of America. Now, a sample would be the subsection of that population that we're going to study. And a lot of times that'll be participants in a study. So if let's say we wanted to see how the COVID-19 pandemic affected college freshmen across the United States. Now, it's going to be hard to collect data on every college freshman across the United States. So instead, we'll get a sample that's representative of the population of college freshmen in the United States, and then do our tests on that sample. And from that sample, we can go and infer on the population that we took the sample from. Okay? And it's important that we get a representative sample of the population in which we're studying, right? There's a lot of college freshmen out there. However, they come from all different backgrounds. They come from different environments. They come from different neighborhoods. They could have been affected in different ways for different reasons. So we always want to pinpoint so we can narrow it down to inner city college freshmen, rural areas college freshmen that live in the suburbs. You could break it down by ethnicity, by race, by socioeconomic status, and so on, by athletes, by non-athletes. We could break it down by honor student versus non-honor student, right? There's many different groups and things to do, and this is what research does. We could look at one broad, how did the COVID-19 pandemic affect college freshmen, and then we could do hundreds and hundreds of different studies by tweaking what exactly we're looking at and what population what sample from that population we are using and focusing on, or what questions are we asking. Okay, so one research strategy that I want you guys to know about is correlation. So a general definition is an observation that two traits or attributes are related to each other. Then the scientific definition would be a measure of how closely two factors vary together, or how well you can predict a change in one from observing a change in another. Okay, so I don't know if anyone ever heard the saying correlation is not causation. So just because two variables are correlated does not mean one variable causes the other. Okay, so a positive correlation would be between 0 and 1, okay? And that indicates a relationship. Two things increase together or decrease together. And so a famous example that's used to explain correlation to students would be that there is a positive correlation. That means when one variable goes up, the other variable goes up, between ice cream sales and violence. So you could see that when ice cream sales go up, violence usually goes up. Could you say that ice cream sales cause violence, or violence causes ice cream sales? Most likely not. Most likely ice cream sales do not cause violence, or violence does not cause ice cream sales. However, by viewing that relationship, we could ask ourselves, is there a third variable at play that is driving this relationship? And what we find in this study was that it's actually the heat that creates that relationship between ice cream and violence. The hotter the weather is, crime seems to go up for various other variables. Now, why? People seem to be more aggressive when they're hot. More people are around other people when it's hot outside. Right? When it's cold and people are inside and away from each other, there's less chances of there being violence. But if everybody's around each other, there's more chances of being violence. So correlation does not mean causation. All we could say is that there's an association or a relationship between the two variables. Right? A negative correlation indicates an inverse relationship. Right? As one thing increases, the other thing decreases. Okay, so In general, a negative correlation is the more cigarettes you smoke, the less time you usually have on this earth, right? So there's a negative correlation between life expectancy. So as cigarette smoking goes up, life expectancy goes down. Now, could we say that smoking cigarettes causes a lower life expectancy? We can't say that unless we're controlling for any other possible variable that could be leading towards the lower life expectancy, right? So smoking could have an impact on your life expectancy going down, and they can be negatively correlated. However, there could be other factors as well. People that smoke cigarettes might partake in other risk-taking behaviors that lower life expectancy, right? Because if we say one causes the other, then there really wouldn't be these 90-year-olds that are smoking and been smoking their whole life. Right? So there has to be other factors at work. But we can say that we can observe a relationship between the more you smoke, the less your life expectancy is. So the correlation coefficient provides a statistical measure of how closely two things vary together. So I'm going to jump to here. So this would be a perfect positive correlation. So again, you could be tested like this on your test, right? So I want you guys to understand graphically what a positive correlation would look like on a scatter plot and what a negative correlation would look like on a scatter plot. So in this case, it's going from left to right, and these are all data points, okay? And when the data points line up in a perfectly straight line like this, then that's a perfect correlation. That means as one goes up, another goes up. Now, there's not many things out there that are perfectly positively correlated, but two variables that are strongly correlated together throughout, the time of testing is height and weight, right? In general, as someone gets taller, they also get heavier, right? So there is a strong positive correlation between height and weight. And this is how that would look graphically, all right? It probably would not be a straight line. This is your hypothetical perfect correlation. But anything over like a 0.8 would be considered a strong correlation, a very strong correlation, right? On a scatter plot where all the dots are all over the place, that shows that there is no relationship, right? You can't really draw a line one way or another here, right? There's no pattern. All the dots are scattered all throughout, and this is your hypothetical zero correlation, meaning that there is no correlation, and this is a perfect negative correlation, right? This is when one variable goes up, the other variable goes down, okay? And you can see here that R is a negative. So this should teach you that a positive correlation, the closer you are to 1, the stronger the positive correlation is. No correlation or no relationship, the closer you are to a 0 is the weaker your correlation is. And in this case, in a negative correlation, the closer you are to -1, the stronger the negative correlation or relationship is. All right? And correlations are graphed on a scatter plot. So right here, we could just graphically look at, right, this is a measurement of optimism and health behaviors. So you could see that the line drawn right here, the line of best fit, is going from left to right. And you can see how the dots fall, closely to the line in a way. And in general, the line goes from left to right going up, right? So we could see right here, even though we don't have the actual correlation number, and I'm not going to be testing you guys on actually solving for correlations, etc. When you go into statistics and research, that's something you'll learn there. I just want you guys to get a general understanding of correlation. So just by looking at this graph, a question on your test could be, Is this a positive correlation or a negative correlation, right? So this is definitely a positive correlation because it moves from left to right. I mean, if I had to estimate what would be the number here, you could see down here a lot of these dots fall really close to each other. Up here, some are a little far away, but in general, you see a trend. This would be something like a 0.65 or a 0.75 correlation. So it'd be a medium to a strong correlation. If you're, putting a number on it. So again, correlation and causation, no matter how strong the relationship is, correlation does not prove causation. A correlation coefficient helps to provide a clearer view of the world by revealing the extent to which two things relate. All right. So an illusory correlation is the perception of a relationship between two variables when only a minor or no relationship actually exists. All right, regression towards the mean, I'm not really going to ask you too much about that. And then as far as we'll just jump into experimentation. So we're not going to focus on regression towards the mean. We can stop right here. And I really want everyone to understand these concepts behind correlation. And then research strategies, so there's experimentation. With experiments, researchers can focus on the possible effects of one or more factors in several ways, right? They can manipulate the factors of interest to determine their effects. They can hold constant, also known as controlling, other factors, right? We can have an experimental group and a control group. All right, so a lot of times what the experimental group will get a treatment and the control group will get no treatment. Okay, so we could take, and this is going to go into a double. So I'm going to give an example of a double-blind experiment. And this is actually one of my favorite experiments that was done on positive thinking and illness. So these participants partaked in this research study, and they took half of the participants, after testing them, had like a negative outlook on life, right? They always expected the worst. They would always think that something was going to go wrong, right? And the other participants had a more positive outlook on life, right? They always had a positive outlook on the outcome of any situation, right? So they had these two different personalities. And what they did was they took them into a research facility, and it was a double-blind experiment. So no one knew if they were getting injected with a cold virus or not, right? So what were they testing? They were testing to see if you have a positive attitude, are you less likely to experience symptoms of a cold? And it was a double-blind study because neither those in the study or those collecting the data knew which group is receiving the treatment. Treatment's actual effect can be separated from potential placebo effects. Okay, so those who were collecting the data on this did not know who was injected with this drug, and those with the virus, and those who got the virus didn't know they were getting it or not. Okay, so the participants knew they were in the study, but they did not know whether they were getting it or not, right? So they were given a pill, right? And half the people in the study got a pill that contained the virus and, give them a cold, and the other half didn't. And the people that were the scientists that were collecting this data did not know which participants, when they were, plotting their data down, they didn't know what participants got it or not, right? So it was that's called a double-blind study. When the participants don't know who's getting what treatment, and when the data collectors don't know who got what treatment, all right? That leaves out a lot of bias. And what they found was that the participants that had that positive attitude were 80% less likely to feel the effects of this virus, of a cold. So just by having a positive outlook and believing that they were not going to get sick, they did not get sick. And since participants knew there was a possibility, you could see the positive people who did get it showed less symptoms, and the negative outlook people who didn't get it, they even showed to feel sick. And the negative people who did get it showed symptoms of being sick a lot more than the positive people who did not get it. All right, so that's an example of a double-blind study. So a placebo effect involves results caused by expectations alone. Okay, so we tried to limit the placebo effect in a double-blind study. One way we test the placebo effect is when we do drug studies. So anti-anxiety, anti-depression medicines, blood pressure medicines, a lot of different medicines. They'll do a study where they'll test, fish oil, lots of different things. So they'll test a certain drug looking for a certain outcome. And again, some participants will get a placebo, which they think they're getting the drug, but they're really not. Right? So let's say I take half of you in the class, and we want to see if fish oil increases memory. And I'm going to give half of you, all of you think you're getting fish oil, but half of you are getting a placebo, which is not really fish oil. Now, you guys are probably too young to remember Space Jam, even though Space Jam 2 is coming out. But for those of you who ever seen Space Jam with Michael Jordan and the Looney Tunes, well, at the end of the movie, hate to ruin it for you guys, at the end of the movie, the Looney Tune team was losing by a lot. And Bugs Bunny said they got this secret sauce that they're going to give to this secret drink that they're going to give to everybody, and it's going to make them play great. And they all believed that this drink was really going to make them play great. And it was just water. But they thought it was this special drink that was going to make them play great. And when they all took it, they all played great, and they beat the Monstars. Right? And that's an example of a placebo effect. If you think what you're taking is actually going to help you, a lot of times it will. Right? And there's an argument in psychology that a lot of the antidepressant medicine effects come from a placebo effect. If the patient thinks because they're taking this pill, they're going to be less depressed, a lot of times you'll seem to be less depressed. I mean, think about it. If this happens with a lot of things. If you're given a pill and told that it's going to help you with something, you'll feel better. Right? That's the placebo effect. All right? And we always try to control for that to really see if whatever medicine we're testing or therapy we're testing actually has an effect. And the dependent variable in an experiment is the factor that is measured, and the variable may change when the independent variable is manipulated. Great. So in the case of fish oil and memory would be the dependent variable, and fish oil would be the independent variable, and we manipulate this independent variable of fish oil by giving maybe 20 milligrams, 40 milligrams, 60 milligrams, and a placebo, which is 0 milligrams. And the dependent variable is memory. And then we look for a change. Is there a change when you get 20 as opposed to 40, as opposed to 60, as opposed to 80, as opposed to 0? Is there a difference between getting 0 milligrams and 80, etc.? All right, so the rest of this, I want you guys to read. So there's a lot of different ethics, etc., with the APA, which is the American Psychological Association. There's certain criteria for animals. There's certain criteria for human subjects. And as far as the ethics of APA, in your book, it goes into detail about the APA ethics, and I want you guys to get into that. The next so we'll just go right into the other statistical reasoning, everyday life, part 2, and we'll talk about measure of central tendency. Now, I'm sure you all have heard of the mean, right? It's the average. All right, then we also use 2 other measures of central tendency, which is the mode, which is the most frequently occurring score in a distribution, or the median, which is the middle score. Okay, and a lot of times the average is not representative of what most people are doing, right? If we're looking at people and an average of people, okay? So in this case, a lot of times it will be skewed, meaning a mean does not always represent what the actual average of the whole group is, okay? And income usually drives up the mean when you're measuring income of a population of people, right? So you'll see here that we're measuring income and we measure it 30, 40, 50, 60, 70, 80, 90, 100. Then we have a mean of 140. So the average income is $140,000 per household, right? Right. So we took a bunch of households and we measured the average, and it came out to 140,000. All right. And we see there's 3 households here. One of them makes 180, one of them makes 950, and another one makes 1,420. Then you see here the mode, which is the most frequent households make 40,000, and more households make the median, that middle number that separates the amount of households on the left from the right, make 60,000. So you can see here 60,000 is a better representation of what most households make. However, this average is more than double. This mean is more than double that 60. And it's more than double that 60 because these outliers, these 3 very high household incomes, are driving really what most people make and skewing. It's called being a skewed distribution. It's skewing the distribution and driving that mean up, when in reality, most households are making 60,000, yet the average says 140,000. Okay, so statistical reasoning in everyday life, describing data. Measures of variation reveal similarity or diversity in scores, right? There's something called a range. The range is the difference between the highest and lowest score in a distribution, right? So the range here would be 1,420 minus 30. That's the range, right? The standard deviation is computed measure of how much scores vary, amount the mean score, and a normal curve, which is a normal distribution, is symmetrical, okay? So this is what a normal distribution looks like, all right? And the normal curve, one that we could think about it here, is the Wechsler Adult Intelligence Scale, which a lot of you guys will know as an IQ test, right? The most famous intelligence score test that we know of. And this is taken from population data. So in general, when you get enough data on a subject, you'll see that it becomes a normal distribution. Okay, so in a normal distribution, there's a mean, right? And the mean equals the median, which equals the mode. So a normal distribution is not skewed like this skewed distribution of income above. Okay, so intelligence in a population is a normal distribution. And you can see right here that 68% of people fall between IQ of 85 and 115. Okay, so this right here, this 100 to 115, you can see that's 34%. That distance is considered a standard deviation. Okay, so a standard deviation is going 34% one way from the mean. All right, so if you're 1 standard deviation above the mean in an IQ, you get 115. If you're 2 standard deviations above, you score 130. If you're 3 standard deviations above, you're 145. And, someone all the way out here at 145 and above, you're talking about Albert Einstein. Okay? So that's a normal distribution, and the same works that way. So a normal distribution, the mean equals the median, which equals the mode, right? So that happens right in the middle. The mean, the median, and the mode, all that falls right in the middle of a distribution, and then it's normally distributed, right? You could see here, right? This is called a normal curve. All right, last thing I want you guys to know about is statistical significance. All right, so statistical significance indicates the likelihood that a result could have happened by chance. It does not say anything about the importance of the result. So again, similar to correlation, and even more so, I don't want to test you on the numbers. I want to test you on the concept of statistical significance. So in psychology, in general, we'll set our significance level at 0.05, meaning that after we run our research, we're going to test that did we get this result by chance? And if we could say with 95% confidence that we did not get this result by chance, then we say the result is significant, right? That still leaves a 5% chance for error. So if you look at a research study and you'll see that something was significant at the 0.05 level, it means that the researcher states that they could be 95% certain that the results they got is not from chance, but that 0.05 is 5%. They still give a 5% chance that they might have got these results by chance. All right, and also then a stronger statistical significance would be 0.01, right? So if you're significant at the 0.01 level, that means that the researcher conclude that the results they got, they could be 99% confident that they did not get the results by chance, meaning there's a 1% chance that they got the results by chance. All right. So this is chapter 2. These are the main topics I want you to know for chapter 2. Check out the quiz, the practice quiz on chapter 2. As far as chapter 3 goes for neuroscience, there'll be another video coming up soon. Until then, I want you all to watch the video that I did post, the neuroscience hip hop music video. And you all have the opportunity to take a quiz that's for extra credit to be added towards your grade based on the video. The video is very educational and will teach you a lot about the basics of neuroscience in a fun way.